So welcome back to part 9 of Machine Learning Bootcamp. So in this video, we'll be actually deep diving into what all different machine learning algorithms are out there. What's the meaning behind each of them? When to approach this type of algorithm? And we'll be taking a look into detail into Scikit-learn as well, the most popular Python machine learning libraries, which is used widely. So if you go to Kaggle as well, if you go to other machine learning competitions as well, there you will see a lot of submissions. If you go through them, you will see a decision tree, random forest, um, naive bias algorithms, and uh, various regression algorithms as well. All of these come under Scikit-learn as well. So it is one of the most popularly used library for machine learning algorithms. So we'll try to cover that as well. Now, talking about machine learning, so in the previous videos, what we have covered all the prerequisites that are required to to start the actual machine learning bootcamps, so that we will be able to understand what we are doing, why we are doing, and what's the reason behind a certain step. Even even if that step doesn't seem too much necessary for you to understand in the earlier stages as well. So, if you haven't watched, please go through them, watch those videos. They're really helpful. And now coming towards this one, machine learning. So what is actually machine learning? As the name suggests, we are enabling the machine to learn from its past mistakes. How? Eventually, like, uh, suppose you are given a child to train. So what to do? One way is you like monitor what the child is doing, correct him at every step, and say like, do not do this, do this, and then he tries to copy the step, it fails at a certain point, and then you give the directions again. That is one part. Now what can be the other way? Like there is a task given to you, and you say like you have to do all of this. Once a child tries, you can correct in the end. Oh no, you could have done this. So that's other way. Or you could have learned, enabled him to figure it out himself. So based on that, various machine algorithms are also categorized, like how you enable the machine to learn from its past mistakes. So we'll be covering them in detail. These are the types: supervised, unsupervised, semi-supervised, self-supervised, and reinforcement plan. So let's get started. Now, coming towards the first machine learning algorithm, which we are going to cover. So let's start with supervised learning. What is supervised learning? Okay, as the name suggests, supervised. So what you do here is you monitor each and every step of the model. Like you give the model input and output as well. And from there, the model defines what all the steps it has to follow. Uh, like suppose you give certain classifications that, okay, the house ranging between 20 to 40 lakhs is C tire, between 40 to 60 is B tire, 60 above is A tire. You give certain aspects as well, that it has certain criteria, then ABC. So now when you give a prompt, based on what you have made the model learn, it will like calculate, okay, the house can belong to this as well. This is like one part of supervised learning. So you provide the input, you provide the direction to the output as well. What the model has to figure it out, the actual algorithm, which the model is actually going to use to find a way to that output. Okay, so that's supervised. It takes the maximum amount of input from the user, or let's say it consumes the max amount of resources from the machine. That's one drawback of that. Now, if you go towards the link, that's a Google Learning link. Go through and check it out. It's super helpful. Uh, like Google wants that. So supervised learning, there's just different differences. So okay, that's it. And if you go through this image, and let's say yes. Okay, one of the most different characteristics is label data. Label data is what? Like you have labeled data, like 20 to 40 LP, 8 CDI. That's how you label the data. So based on that, the ML model trains like, okay, I have to do this, and then it builds the output. Like this is one kind of label data machine, ML model. If you do this data, creates output. As simple as that. That's supervised learning. Now, if we go to unsupervised ML, and yeah, unsupervised ML is like how you can take it. You can take it as clustering. Sorry, clustering. Like you are giving 1,000 bunch of shapes in front of you. So, what your first reaction will be? Like if you're given an unknown puzzle, if you're in, let's say somewhere in interview, given an unknown puzzle, you are given 1,000 shapes in front of you. So what your first reaction will be? Okay, let me first sort like each kind of shape, like certain elongated one-sided, triangular one-sided, circle one-sided, those are square one-sided. So you don't know like what each shape means, but you are just like forming a group. Okay, so what happens when a new shape is given to you? You think, okay, this is more like this. No, this is more like this. I'll put it into this group. So you have no label of the groups, but okay, you are just like organizing them on the basis of their shape, texture. Similarly, that's how unsupervised learning works. Not just based on shape. Let's say yes, different kind of colors as well. And if we take certain unsupervised algorithms, um, let me clustering, K means clustering, neighbors clustering is one of a kind. Like you have to form the clusters. And okay, we'll cover the name and certain type of algorithms and we'll deep dive into each one of them. This is just the overview. So unsupervised, basically, you don't have the label for the data. You just have the data. You just want to categorize. You need to find, extract the maximum amount of information you can from that unsupervised data. That is unsupervised and machine learning. You are not telling machine anything. Now comes the semi-supervised. Semi-supervised, as the name suggests, it's a combination of both labeled and unlabeled data. So what happens is, uh, you give certain amount of labeled data at the initial stages for machine to learn the pattern. Then you, for test, for training, you give a large amount of unlabeled data as well. So what happens when you give initially the, let me get it, just labeled data for the model to like learn the pattern. Then you give the unlabeled data for the model to train. So what happens when you give a certain low amount of labeled data? As labeled data, obviously you are giving a data and the label alongside as well. It consumes more cost. So to prevent the costing, semi-supervised machine learning algorithm was invented that works better than unsupervised and takes less cost than supervised algorithms. So you provide a certain amount of label data, let's say 10 to 20% at the initial stages for the model to learn. Then you provide a large bulk amount of unsupervised data for the model to train on that. And after that, you test and if prediction is goes like it's simple. That's one of the most easiest way. Small level data set, model training, large unlabeled data set, then it helps to predict. So there's the algorithm. Okay, let's try the label data set, pseudo label data, and yeah, you can do as much amount of free training as you want. Okay, now comes the third, fourth type, self-supervised. Self-supervised is more like when the model self find out, okay, I'm giving this data, I'm giving this input, am I predicting it correctly? Uh, Let me take you the example. What can be the good one? Oh no, it tells you much into there. Um, Failure of considering the pre-trained model. That will go to compilation layer. That's semi, not semi self-supervised. Self-supervised, how can I describe it? It's more like a combination of unsupervised And okay, that means us to find exactly what which I can use. Um, okay, it's just opposite of semi-supervised. That's definitely better. So you give unlabeled data, the model like defines the shapes and certain values. Then you use the supervised learning labels and certain things to tell the model like, hey, you have done the very good job. You have like formed the groups. This is the meaning of each group. Now proceed. We use NLP, use a pre-trained model in that way often. Like basically, the pre-trained model is a model which is trained on large amount of unlabeled data set. Then you give it a certain labeling value, certain amount of things. Then it like trained on this. Like in terms of NLP or AI, you can take like you take a you have seen so like creators or algorithms or like what they take a large amount of pre-trained model, they train it on their own data set. So what does a pre-trained model look like for AI? Assume you know what are all the words in the dictionary and what is the meaning behind this, but you don't know how to form sentences out of them. So that's where the contexting of training a pre-trained model comes in. Let's say pre-trained model will have all the words in the dictionary, all its meaning, pass, good, better, best. It has all the definitions, attention, which we have discussed in the past as well. So it will have all kind of data. But how to form sentences, what kind of sentences to frame, what language structure to follow, you will get that from uh, the training data set. Okay. Now comes the reinforcement learning. Reinforcement learning is just simple robot training, which we're very much aware of. Punishment and reward. You give the bot a certain task. If it is good, reward. If it not as good, punishment. And from there, robot or AI has to know like you've done the right. So yeah, reinforcement learning perfect example is that you get you give AI certain task. If AI is able to do that correctly, you give certain kind of reward like appreciation. You've done this good, this good. So that goes in its response like okay, for this question I have to give this answer or similar type of answer. And if not given correctly, like punishment system, so it tries to generate a new type of answer next time. So that's how many LLM work nowadays. They give a certain like response, whichever you prefer. In their testing phrase, that gets appreciation. It tries to generate more of a kind. The next one. So that's just a brief overview of what algorithms are there. Now, a question arises, okay, I know this kind of algorithms, but what do each algorithm mean in detail? And like, how can I call these algorithms? That's a good question. So we'll be covering them in detail. Like, okay, classification and regression, these are the supervised learnings and unsupervised classification algorithms. So, yeah, we'll be taking a look at them as well. Most probably in the next video. Now coming to Scikit-learn. So what is Scikit-learn? If you go to documentation, official documentation of Scikit-learn, uh, I will paste it in the video as well. So if you go to the official documentation, it shows like what all algorithms out there and model selection, preprocessing, and everything. Preprocessing is something which we have covered, feature extraction most. So that's just basically a code snippet, how do you call different stuffs as well in Python. So extract train this data, preprocessing standard scalar. Standard scalar is kind of a function which like standardize your data into kind of numerical values that has been required to your model. SQL data set, linear model. So it contains a vast amount of like functionalities. When you go through this documentation, you will find a lot of them. But don't try to just model up what all functionalities are there. You can take for beginning, that's a really good structure they are given, like how to load the data, That's on the Scikit-learn as well. So for data sets, how to load the data, uh, how do you actually can, um, okay, this is just data set how to load this is not this listing, but yeah, how to load, most probably you use a data frame for loading or like consuming your data, and after that, let's go to this thing to suggest, okay, done data, what it contains, yeah, this is more about. But okay, there's this simple math out there. If you want to go over it, you can take a look. But speaking of data set loading, it's just more of like how you want your data to load. Most probably, we use Spark in Notebook by Spark. We use data frames. We use CSV formats and different formats as well in the notebook um, while doing certain queries to load the data effectively. So if we open a notebook out there, okay, Jupyter notebook, just you know, okay, that's a previous one. Suppose if I'm using most systems used by pandas for data loading, you can try other features as well. So my data routing model selection is the one you have to integrate and yeah, data sets, reclassification, these are all practices. So yeah, that I will so let's see if we can get the report from somewhere. Okay, not available, but yeah. So what you just need to do, go to Kaggle. Uh, yeah, that should be very much. Let me if yeah, society. Yeah, that was be nice. Yeah, okay. We are using the CSV, and that's what you want as index from the data bar. So pandas, you can use the various functionalities which we have covered in the pandas, how to load the data, how to load in different formats. If you want data frame, you can take data frame. But yeah, we mostly prefer CSV as most of the models were the CSV data sets. So take a reference from there, take any completion, some notebooks. But yeah, go to that video pandas. I have told you like what all type of data loading we can do. Take render status, basically splitting of the data, and it's also a functionality from Scikit-learn as well, where you from Scikit-learn model test train split, where you define like how much data you have to go to test, how much you have to take to train. So most popular is 80-20 splits, like 0.8 to uh, train, 0.2 to test. Yeah, test size 0.33. This is for that definition. So test frame split contains all those columns like x, axis. So that's just x training data. And okay, it returns a four variable type output. So I have one, I'm not sure if there's given like what it returns. And yeah, parameter array, test size, frame size, if you give both of them, random state, take from linear, not linear wise, like random state, take this for test, take this for train. Shuffle if you want, stratify. It returns a splitting list that just basically returns four value, x train, x test, y train, y test. And if you really want to like Google it out, so test train return the which is another kind of test. Test size, random shape, shuffle, stratify, whatever we have learned. Data frame, we provide this, like test data, x test, all the test columns, y these values, all of them into input, and you get x train, x test, y train, y test. It's just like, yeah, kind of divide your data set in complete randomness. So for the model, it will be beneficial while it has to test and makes it is more like an exact copy of the test data. Uh, you can go through and look at all of them. But yeah, that's just a topic. Data preparation is like feature extraction, data cleaning, data pre-processing, all those functionalities. I've covered that in the previous video. Please take a look at that. Model selection. Okay, this is some important section. Supervised and supervised learning models. Um, okay, we will covering all those models in detail. So from there you will be like getting the idea. Okay, this is a certain problem I've got. What model do I need to select? Fine tuning. Um, okay, every model you have to provide a certain set of inputs. That's just basics of programming. Like whenever you call a function, suppose that you want to call a simple function that add two numbers. So you, as parameters, you provide input to two numbers. Similarly, when you call any machine learning algorithm, there are certain parameters that you can define. Like, okay, I want that much level of randomness. I want that much level of creativity. I want that much learning rate. I want the average of best three answers. All of those parameters you can like choose any which are provided for that particular type of model. And we call it a hyperparameter tuning for optimizations. Then comes the prediction. Like, okay, certain model has predicted something. How do you test? How do you test if the model is predicted certain thing that is correct? So there are certain tests. Yeah, that test we can cover in detail, here only. And that's where the maths come really interesting. Mean median mode, no use. What about the actual machine learning test? Yes. Accuracy, okay, as the name suggests, the actual score minus the correct score minus the actual score. Precision, how much model output is correct to each other. Okay. Uh, for fine-tuning models, you can have certain numbers, but for happen, yes. Let me just give you a brief overview of what all those numbers are and what do they mean. So, true positive matrix, what do we call that? Yeah. What is true positive? When certain kind of, let's say, yes or no model. I am taking just as an example. So what is true positive? When the output has to be yes and model predicted yes. False positive when the output has to be no, the model predicted yes. False negative when the output has to be yes, model predicted no. True negative when the output has to be no, model predicted no. So from here, say what is accuracy? Accuracy is true positive plus true negative when the model says predicted correctly upon the total number of predictions. Similarly, what is precision? True positive upon true positive plus false positive. Like when the model is predicted correctly, when it has to predict something. Uh, then comes your ROC. ROC is more like okay, yeah, there's just a simple chart that you have to go through. Sensitivity is basically ROC. I'm not wrong. Yes, we call it something true positive, like how much model has been able to record for the actual positive values. And F1 score is basically two times positive into the account positive precision plus reversal. So for F1, the simplest formula will be okay. Let's not just do the maths out here, but yeah, it's very simple. Let me just get a simple problem. Take it this two times precision recall, second precision plus recall. So these are certain kind of most used matrices out there. ROC score as well, if we get that clearly. ROC is something which uh, we call over context or something like that. So these matrices become handy when we want to like predict, okay, what is the model's performance, where we can compromise. Uh, just to give you an overview where you can compromise, let us go through this matrix and decision recall reference score, veteran loss, AUC ROC curve, true positive rate, true negative rate, the recommended correlation of PPR versus FPR, false positive rate. And it's if ROC is one like it's going correct, then perfect model, and if it's less, means you have to just find the area under this curve. It's that simple. And yeah, mean absolute, mean absolute. These are certain mathematical regression matrices where you calculate them in form of like you want to get some numerical values. These comes in more handy. RMS is the most used. Root mean square. So just to sum up, root mean square is basically um, read it backwards. Square the output, take the mean of it, then root it. Square the output, take the mean of it, then root it. Simple. And R square is just basically 1 minus square upon itself plus string is how to store variables. So all this type of stores that you can go through, that you can learn. Um, yeah, just okay, moving very briefly. So you can check all those models in detail, and yeah, you can try them out as well. All these courses, basically, you can go through the mathematical implementation. And just to give you an overview, like suppose there is a smoke alarm. So in smoke alarm, which kind of error you can bear? Like when it has to be, when it has to ring, it doesn't ring, or sometimes there is a false alarm. So for in case of smoke of fire alarms, you must have got a lot of number of friends. Oh, this is false positive. Why? Because it doesn't have to ring. It doesn't supposed to be ring the alarm, but it ring on certain occasions. Why? Because in such scenario, we cannot compromise with the false positive. Like it doesn't ring the alarm when it is supposed to. So that's why we compromise on that side. Now, in some cases, there are certain factors when we want it to give negative, only if it has to give negative, like HIV score and other scores as well. So that's where you don't compromise on false negative, you can compromise on false positives. And similarly, two negative, two positives are always desired. So no model can achieve 100% accuracy. If that's the thing in machine learning, nothing is 100% perfect. If your model in test or training is giving 100% accuracy, it is overfitted. You have to retrain, you have to drop out the weights, you have to do a lot of stuff. But yeah, the ideal accuracy you should target is 0.85 to 0.95. Anything above that, it is overfitted. Anything below that, it is underfitted. You need more data or define the levels more quite clearly. So yeah, that's it from that side. In the next video, we'll be covering each algorithm in detail, and by the time, uh, I'm also like trying to make it more enhanced or like visually appealing. So been working on this like sidely to provide okay for the algorithms to provide you more detailed insights on each one of them, how each algorithm works, what are the different hyperparameters you can tune, how do you enhance the performance as well. So this is the link to the website. Once it is completed, we'll provide the link in the next video as well. Before that, you can try it out. If there are any suggestions, you can please provide in the comments. And yes, that will be mostly. But okay, there are certain announcements. If you haven't tried the GitHub Copilot app, or if you don't have the license, that thing is a real killer. Like it has all the powers of GitHub Copilot. Just code plus a custom agent at your hands. And yeah, GitHub is really good something. Very impressive. Feel free to try that out. Read the documentation about it. You will get to know a lot of things that this app can do. I've been using that a lot. And yeah, so consider this the end of this section. We have, I will say, we have covered all the required sections, prerequisite, not prerequisites, yeah, just the introduction chapter of the machine learning. Now we'll be moving towards each algorithm in detail in the next one, where we take the help of this as well, if I'll be able to complete that. And yeah, we'll go deep dive into each algorithm, find what parameters it contains, and how to play around with them as well. So that will be really well. And for those, you will try to go earlier, you try to go real story, like to explain each algorithm more clearly. So there shouldn't be any confusion which algorithm to use, when to use, how to use. Yeah, these are model evaluation and why it is so important. We can also cover them in detail here as well. And validation deep, then comes the deep learning. Okay, that will be very fun. And after that, yeah, you can we can move towards the AI as well. So so yeah, that will be pretty much it from the session. So by the time go through those algorithms as well, take a deep, take a precise look at well, if you want to just to overview like what all these algorithms are. And yeah, from the data you can explore the Scikit-learn documentation as well. Uh, Go to Kaggle, try one or two competitions, starting competitions as well, where they teach you about all the different algorithms and other stuff as well. So that will come very handy as you move forward. Um, Coming to the next part of this, we will be covering supervised learning and unsupervised learning and all the algorithms in detail in the next section. Until then, like you can learn more about those methods, why we complete them. So by the time keep learning, keep iterating as well. Kaggle is a really wonderful platform for like all the AI/ML enthusiasts. You can give all the competitions and like You can use the datasets for the datasets, understand how it works, understand how to query on the real datasets, try that out as well. And yeah, if you feel any questions or any solutions, please uh, comment out, like and share and subscribe. And you can post on like socials as well, respecting being with you. So yeah, that's it. Very much from this side. Keep learning in public, and yeah, take care. Bye bye.